All right, here we go, y'all. Moving on to section 8.6. We're going to be solving equations with radicals. And we're particularly going to use a property called the power rule. And the power rule is a simple rule. And let me show you how it works. So say if I said x equals 1. The letter x equals 1. How many solutions are there? Well, there's only one, right? It says x equals 1. But if I squared both sides now, if I squared the left side, and if I square the right side, now this becomes x squared equals 1. Right? So now, what is our answer for x? Well, x can be 1 or x can be negative 1, right? Because if I square 1, I get 1. If I square negative 1, I get 1 as well. Okay, so the power rule, if I could say that correctly there, is basically doing this right here, which is squaring both sides. Okay? And there's one thing though, if you're going to square both sides, notice what happened here. We got two solutions, okay? And so basically what that means is you're going to need to check your answer. We have to go back into the original problem, plug them back in, and let's make sure that both answers are correct, okay? Because we are going to get some answers that are actually not true. Basically meaning if I plug in the x right here, it doesn't equal 5. And if that's the case, then you would cross those answers out, and that wouldn't be part of your solution. Okay, so let's apply the power rule. Okay, I'm going to square both sides. And if you're wondering, like, well, why are you just randomly squaring both sides? Like, where does that come from? Well, because I'm trying to solve for x, right? So I have the square root of 9x plus 7. So what is the opposite of a square root? Well, squaring, right? So if I want to get rid of this radical, I have to do the opposite operation, and the opposite of square root is squaring. So that square crosses out with that square root, and I get 9x plus 7 equals 25. Okay, not bad right there? All right. So then what I'm going to do now, I'm going to solve for x now, right? So we're always going to do the opposite operation when we're solving for x, right? So we have to do the opposite of adding 7. So I'm going to subtract 7 from both sides. So wata, those are gone. So I get 9x equals 18. Now the 9 is being multiplied. That means 9 times x. So the opposite of multiplying by 9 is dividing by 9. And I get x equals 2. Okay? And so in this case, we only got one answer. So, I mean, you know, that one's going to check out correctly. We'll get to ones where they don't check out, but when we get two answers, we always want to check both answers there. Okay? So, hold up, y'all. Anytime we square both sides of an equation, we need to check our answers just in case one of them is trying to creep. All right, so make sure that you check your answers, or else they may try to creep up on you. No creeping. All right, so let's dive into example number 2 then. All right, example number 2. We're solving, and here's some steps here. You might want to pause it and just write these down. The way that we solve radicals is you first want to isolate the radical, and isolate just means get it by itself. Okay, so see how this is a square root right here? So you want to get this so it's all by itself, so there's nothing behind it or there's nothing in front of it. Okay? Then once you have the radical by itself, you're going to do step 2, which is then to do the power rule. That's what we just did in example 1. And then you're going to solve. But make sure that you check your solutions. And we'll do that in this guy right here. So let's tackle this guy. And let's get nerdy. Okay, so first step was to isolate the radical. So I want to get the radical by itself. So I'm going to subtract 2 from both sides. Okay? So I'm going to subtract 2. So I get radical 5x plus 3. And those are gone, right? Equals negative 2. Now, I want to get rid of the radical, so I'm going to do step 2, which it said to do the power rule. So I'm going to square both sides. Oops. Check that. If I can get rid of that there. Try that again. So I'm going to go and square both sides. So if I square both sides, the square crosses out with the square root. So I get 5x plus 3 equals 4, right? Negative 2 times negative 2 is 4. Subtract 3, and I'm going to get 5x equals 1. And then I'm going to divide both sides by 5. And I get x equals 1/5. Okay? And normally when you get one answer, it's going to be okay. But let's just go ahead and check our answer, okay? Check yo answer. Okay, so basically what we do is this, is that we're going to rewrite the original equation. However, we know what x is. X is 1/5. So I'm going to do the square root of 5 times 1/5 plus 3. And that should all be underneath the radical. And then I have plus 2 equals 0. Okay, so is this true or false? Is it true or is it false that the left side equals 0? Because if it's false, then actually we'll say, oh, 1/5 is not the answer, and there's just no answer then right here. So let's see. 1/5 times 5. We'll look at this right here. 5 times 1/5. Well, look. See how the 5's on top and the 5's on the bottom? So that 5 crosses out with that 5, so we're left with just 1. So really we can just say this is 1 right here. The square root of 1 plus 3 and then plus 2 equals 0. Well, 1 plus 3 is 4. Plus 2 equals 0. Radical 4 is 2 plus 2 equals 0. Wait a minute. What? Is 2 plus 2 is 4 equal to 0? I don't think so. So since we checked our answer right there, and the answer came out to be false right here, right? This right here is false. Okay, so you say, well, okay, well then what's the answer then, right? I mean, we solved for x, we got 1/5. We checked the answer and we found out that it was false. So the way that you would write your answer is there is no answer. And the nerdy way of doing that is you put a 0 with a line through it. And this is the nerdy way of saying the empty set or nothing. So it's not 0. This is just the symbol for the empty set, or meaning nothing. There is no answer. Okay, so that's what you would do for that guy.